Hello everyone, today we're going to talk about Newton's second law of motion. And we all know what Newton's second law of motion is. F equals ma, where F is force, m is mass, and a is acceleration. So let's say I have a mass of 1 kilogram, an acceleration of 2 meters per second squared. That means that my force is 2 newtons. This is a really nice equation because it allows us to calculate forces, but in this form alone, it won't help us calculate the position of a particle at some moment in time. To do that, we'd have to advance it to calculus. So we know that acceleration is defined as the second derivative of position with respect to time. So force is then m times the second derivative of position with respect to time. And it's this form of Newton's second law that will actually help us calculate the position of a particle at some moment in time. This form is really nice, but it won't help us get that. It won't help us find exactly where the particle is. We need to advance to calculus. So using this form, let's actually solve for the motion of a particle for when F equals 0. But before we do that, let's actually derive F equals ma. So force is defined as the rate of change of momentum. And momentum is just mass times velocity, right? So we have the derivative of a product, so you just use product rule. Now, if our mass doesn't change, this whole term is 0. This is acceleration by definition. Now we have ma. So we've just derived F equals ma. But no, this is only true for the case where the mass of our system isn't changing. If our mass does change, then we will pick up some mass term. But since usually we deal with cases where our mass is constant, F will be equal to ma. Okay? So now that we derived F equals ma, and we talked about the calculus version of the equation, let's actually solve it for a real case. So let's say that the forces acting on some object is 0. Let's find where the particle will be at t equals 2. And let's assume that the particle starts out at the origin. And also, let's assume that the velocity of the particle is 2 meters per second. Okay, so to solve this problem, it's better to actually visualize it. So here is our number line. This is just the x-axis, okay? And the particle starts out at x, well, at x equals 0. So x is a function of t, right? So this just means the position of the particle at t equals 0, position of the particle at t equals 2. So we want to find where this particle will be after 2 seconds pass on our clock. So right now, our clock shows our clock hasn't started yet. But after 2 seconds has passed on the clock, where will the particle be? And that's what we want to find. Now to do that, we just use Newton's second law. So since F equals 0, this means that m times the second derivative of position with respect to time equals 0. Divided by starts by m, we have the second derivative of position with respect to time is going to be 0. So we just take the integral of this. So if x equals integral of 0, which is some constant c1, sorry, dx over dt is the integral of 0, which is c1. And then the integral of that is just c1t plus another constant c2. Just elementary calculus here. So this means that x of t is c1t plus c2. Now, for x equals 0, we just have c2, implying that c2 is the starting position. And dx over dt is going to be c1, implying this is the velocity. The velocity is constant. So really, we can rewrite our variables into the x of t equals vt plus x naught, where x naught is the starting position. And this is our, we call that the equations, or equation of motion. since we have one dimension of this system. So if our forces are 0, this means that the particle has some constant velocity. It's a completely linear equation here. But if they're non-zero, the equation becomes non-linear. So our particle started out at x0 equals 0, right? And the velocity was 2 meters per second. Yeah, per second. As we see here, this means that x of t equals 2t, and that's it. So at t equals 2, x of t will be 4. Well, x of 2 will be 4. So this means that in 2 seconds, the particle or object will be at x equals 4 after 2 seconds. So yeah, that's how we use Newton's second law of motion to find where a particle will be at some moment in time. If you guys like this video, please share it, and yeah, I hope you guys enjoyed that, and have an amazing day. Bye.